Okay, so first, a reminder, what we are trying to do? The idea is to reconstruct back in time the mean annual growth of different species, and to do that, this is just uncorrected data, so these are not actual trends. This is we still need to filter false rings, missing rings, etc. But to do that, we start with tree cores. We collected many tree cores on different species. Additionally, because tree growth sometimes is not even around the tree, so we also have many tree cookies that we're going to use to correct some of those tree cores. And the entire process was split into three major components, which is the site characterization and sample collection, sample stabilization and preparation, and the sample digitalization and analysis. For the sample collection, we split all the forest in its diameter distribution, and we did that for each species, and then collected a number of samples that corresponds to the diameter distribution of each species. For sample stabilization, we mounted the samples on these tree core holders. We sand and they're glued. They were sanded with, I guess we started with 240, I think. Then on some samples we moved all the way to 800 and then to 1000 on some of them. And for sample digitalization and analysis, we scanned most of them. Some of them, the rings were just too small, as you can see here. Some of the samples had just rings too small, just so small that I think I need to go back and scan them again or take better photos. So these are not scans, these are actual photos of those that have very, very, very thin rings. We took photos on their dissecting microscope, and for those we had to sand them at, I guess it was 1000. But even those, it wasn't enough on some trees, as you can see here on the sample at the bottom. For sample digitalization analysis, the process will be like this. First, we're going to load the images and set the scale in the program. Then we will measure each ring, and it is really important to start with the newest, and also to measure every single ring that we see. At this point, we do not distinguish between false and real rings. We just measure everything. And the last part is to save everything. We save the measurements and also something called the region of interest data. And once we install the program, all we need to do is navigate to our folder where we have our samples, and of course open the program. And as I mentioned before, there are just three different things. The initial one is load the image here on FIJI or ImageJ, and it's really easy actually. It's updates, no. All we need to do again is just drag and drop into FIJI. I'm just gonna take this spruce maybe, and I'm gonna drop it right here. Then the next step is to set the scale. That's something very important. Otherwise, ImageJ will not know what we are trying to measure. And we scanned these tree cores with a ruler, so the idea is to use the ruler as the reference. We are going to go to this option here for line, and then we just click right in the middle of that measurement, and go to the other side of the image. Oh, come on. Let's see. I'm zooming in and out just because apparently it's easier in my computer. And I've been selecting 15 centimeters for all of them just because I find it easier. However, on some samples, we are going to have to select 2 centimeters because the images are much smaller, and of course we couldn't fit the entire ruler. But on all of them, if you see the ruler, just select 15 centimeters as your reference. And then we just go here to analyze. Oops, I just realized that my computer is not recording that menu. Well, the menu here at the top that sadly is not being recorded, it says analyze, then click on set scale, which is it, set scale, and then it's telling us that we selected a given amount of pixels. Then we say that this known distance is 15, and then the unit is centimeters, and then we just click here OK. In FIJI-ImageJ you can also have something called stacks. These stacks are you can load many images at the same time and process them all at the same time. However, because we need to select ring by ring, this might not be necessary here. So just one by one is okay. And you would select global in the case of a stack, and when you want all the images within the stack to have the same scale. Or you can also set a scale for each individual image. In this case, it doesn't matter, we don't have many, so I'm just going to leave it like that and click OK. I see that this image in particular is only 473 pixels per centimeter, which might be on the low side, maybe got scanned too low. I might have to rescan them. Ideally, we want maybe no less than 1,000. Okay, setting the scale, and then once the scale is set, then that's all. I'm only going to zoom in here where I should start, and to zoom in on a specific region in my computer, I press Ctrl and then I just zoom in with the what is that thing called? The trackpad. But I'm sure that every computer might be different. So if I want to zoom in on this ring, I can just do that, or on the bark, or maybe the cambium, etc. That's all we do. There's also this little hand tool that we can use to move things around. We will be moving between the hand and the straight line. Hand is kind of useful sometimes when you want to process things slowly. First things first, we took this sample in November. So because of that, we know that the last ring, or this part here, is the late wood that was already forming in November. We took the samples mid-November, I think. So we are very confident that all this is 2022. And so what we do is literally just point and drop where we believe the next ring starts. Now, once you select that area, you need to press the letter T, and that would add this selection into something called the I guess region of interest or something. And then to keep track of things that you do, I would strongly advise to ask for labels here on this menu, and also to show them all. And that's a good way to know that you're keeping things in order, and also to keep track of what you've measured already. next, and then we press T, next, and press T, and then they will be all sent to this region of interest, I think it's called. Yeah, and then we'll continue with this tree. Let's see if we can do that all, otherwise I might just skip. So important thing is to make sure that we measure them perpendicular, so not like that or not like that. So then this is when I personally go to the hand option, move it a little, and then continue. Don't forget to select, of course, the line, otherwise it will not work. And press T every single time you make a selection, otherwise they will not be saved. If you accidentally forget to do that, then best to go back and start again, because it's really important to keep the rings in order. Really important. Alright, let's see. This sample happens to be super easy. There are others that are just really difficult. Especially some birch trees in the late years. They're quite tricky. I forgot to press T there, I guess. Yes. Done. Might be worth to mention that this is not a perfect method. There are, as all of you know, there are many tools and dedicated software for this, with the benefit that you might have access to a reference and might make corrections of your rings maybe easier, potentially. But in this case, the idea is that we're going to use ImageJ, so we're going to have to work with this. No, that's a little crooked. Well, good that happened. What happens if you accidentally have a crooked line that I don't know, happens to me sometimes. I'm distracted and then this thing moves. Well, it's really easy. Just go back, select, and once it turns, is that blue or magenta? What color is it? I don't know. Green? I cannot see. Well, once you see that it changes color, that's the time when you can move both either end of the line. In this case, I guess we want to correct it here. And perfect. Then we continue. And as you can see, I'm going in like some sort of a zigzag pattern, because personally I find it really difficult to start like right there. I always end up pulling the previous line, so instead I do what you see me doing right now, which is one on one side, the other on the other side, and etc. I find that easier. There. And when the rings are big enough, there's you have the luxury of making micro errors, and it is okay. You see, sometimes I use the zoom, sometimes I use the little hand tool. This one might have been a little to the side, so I'm just fixing it. Perfect. Most of these trees are 80 to 130 years old, so I guess we are not even close to the end. I don't know, I don't remember. I'm sure I processed the sample before, but I don't remember how old it was. It must be pretty old. And again, we are not correcting for false rings at the moment. We are just measuring what we see. In the tree database, we have a lot of information from the trees: basal area, diameter, subwood depth, bark depth, cambium depth, everything, and also information about the rings, how clear they are, where the trees grew, so we can find trees that are less likely to have false rings, and we're going to use some of those as references. Also on some trees is really obvious they are not false rings, and on some trees it's really hard to tell. Almost there, 65. If we find a shortcut to shift between, oops, that's crooked. To move between tools like the line selection and this little, what is it called? Scrolling tool. Then, yeah, you might have to use them. I have not bothered looking for them, to be honest, but maybe I should. Now let's go to the scroll tool. You see how I started to change the angle of the lines? Because again, the rule is that you're supposed to measure them perpendicular to the ring. So coincidentally, now they're changing in angle. And we need to do this because it's nearly impossible to go straight into the pith. So what do you want, Nala? That's the doggy. She keeps staring at me. And we are almost at the pith. Almost there. Well, the last ring I cannot see personally. Would it be fair to make up a ring here or not? I just don't know. Yeah. If there is a ring there, I would assume it is the exact same or very similar length to the other one. Like that-ish. I don't know. Let's just assume that there is a ring there. Personally, if I don't see the other ring, I would just not. But in this case, let's just do that for this exercise. Okay. Took a while. 82 years old or 81 visible years. I think we are okay with this one. Then we go to the region of interest. And then we just need to select them all. In my computer, I'm going to do Command A. And there are two options. We can go up to this menu. Sorry, that is not being recorded here, but it says Analyze, or we can just do it here also. On the menu up here, you would click Analyze and then Measure, which in my computer, there's also the Command M, or we can just click here on Measure. And that should show this table. It shows the label, which is the name of the image, which is why it's really important to label properly the images. It tries to estimate an area, an angle, and then of course there's no areas, there's just lines. We would see an area if we had a polygon. The angle is the angle of the line. You can see how they were almost flat, and then towards the end they were negative when I was changing the angles. That data can eventually be used to estimate some sort of a diameter. But yeah, that's something different that we don't need to worry about today. The slice is if you have a stack that is many images on the same stack. It shows here, it says slice, and then there's slice 1, and then until n, however many images you would have. And the length is the actual length of these lines now in centimeters. I told the program that 15 that I selected were centimeters, so it tries to estimate with that reference, so now it's in centimeters. It's worth it perhaps at some point to decide whether it is best to enter in millimeters, but for now I think it is okay just to enter centimeters. Yeah, I don't know if there's a way to tell the program to increase the number of digits. If anyone knows, please let me know. I don't know how to do that. Additionally, we could I wonder if one could change the scale and tell the program that what we wanted were millimeters. But yeah, I'm gonna leave it like that for now. So the next step is quite important. It's just saving things. What we need to save is obviously the results, and then we're gonna save the results as the same name as the image. In this case, this sample came from Svarberiet. It's a spruce, and it has the name, the number 30, and I will save that. And the next thing that we need to save is this region of area manager. Really important. We are going to go to more. Let's move that to the center maybe. Click here on more, and then save, and then we do the exact same thing. Svarberiet spruce. Wait, what number was it again? I forgot already. 30. Spruce 30. Why do we need to save this? This is really important because in case something doesn't look right, we are concerned about something, the data doesn't make sense, we can always go back to that and fix it. Let me show you now. Sure. I saved as overlay, but that's okay. I'm going now to close this. I do not think you need to save the image, because if you save the image, it's going to be saved as a TIFF file, I guess, and those are huge. It's like 180 megabytes a single image, so might not be necessary. All right, I'm gonna cancel this so that we don't save this. Don't save. Right, and then we end up with a CSV file with all the measurements, which we can later use to process in R or JMP, and a zip folder with all the selections. And this is where things get really interesting, because look, if something is wrong later, and I want to be able to check the measurements in case something doesn't look right, or in the future if something needs to be double, triple checked, it's so much easier if we have access to that, the selections. I'm just gonna say open, and I'm going to select the zip file for that image. Yeah, there it is. So we just opened the zip file for the region of interest, and oops, and I guess we can always say show them all and show the labels. And that's the reason why it's so important to save them. That's what we did before, and we can check anything. If let's say that we go back to some specific year and nothing made any sense, so we think, aha, it's wrong, so I need to double check, or maybe there's a missing ring, or there's weird things going on, so we can always just adjust them, measure again, and save the data. Of course, because I don't think it stores the I do not think it will store the scale from the previous one, so I think it might be necessary to set that scale again. There, then we can tell the program, hey, that's scale. What happens if we do analyze, set scale, and now we tell the program that we want, yeah, let's see, 150 millimeters, and then we select this again and ask them to be measured. This might be actually better in terms of resolution. I didn't think of that. I need to think about this very carefully, because maybe it's best to enter the scale in 150 millimeters. Yeah, instead of centimeters, because I personally like better to see this additional decimal point, because in centimeters we had 2, but then I don't know how precise they are. Yeah, I'll need to think about that. But that's all what we need to do. I'm not gonna save anything. I just wanted to show that. So let's see, birch. First things first, again, as always, we set the scale. Again, I'm using 15 centimeters as a reference. We tell the program analyze, set scale, and I'm going to do 150 millimeters. Okay. And then we can zoom in on our image, and here you see this specific birch might be a little trickier than others, because the lines are not as clear. But one thing we know, again, as with the previous one, we know that we collected these in November, so of course they already had no leaves, so we can be super confident that this line here is the end of the growth period. I will also talk with some experts on the field, see if that it's an okay assumption. But in the meantime, for measurement purposes, we are going to measure all these rings. Same thing, click and drop, and you see that now in the case of this specific tree, the lines are quite crooked, so we need to be careful about that. But as long as we try to do as reasonable as possible. That is just okay. And there's fancy software to do this. There's even algorithms that can detect lines and things, but this is not something that we do on a daily basis, so I think it's just fine to do it by hand. Some of these look like fake rings, but again, not doing that at the moment, just selecting all the rings we can see. And I'm sure we can increase later the quality of the image. I might have to scan this image again because it looks pretty blurry. This line here that you see, I think it's an issue with the scanner, but it's not affecting, or maybe I moved accidentally the sample a tiny bit. So I need to double check that again. I mean, I might have moved it when it was being scanned. Oops, I missed pressing the T on that one. There. Yeah, this part can be tedious, but if you really think about it, you're just literally going back in time. You can see this as a lame time travel from the comfort of your desk. No, I mean, personally, I work with drought and response of trees to severe weather. So you go back in time and say, aha, so that was a bad year, or that was a good year, or. And I'm personally looking at the net tree growth, not necessarily the widths of the rings, but there's a correlation between the width of the ring and the growth. Of course, for me, growth is more relevant. I don't need to focus too much on the width, but there is something to be said about the widths of the rings. Years into the past. I hope it's not one of those 130-year-old trees, otherwise we're going to be here for a long time. Yep, I guess it's an old tree. Nope. You saw how tiny the sample was, right? So these are boreal trees. They don't grow as much. They grow very little every year. I mean, compared to some trees I used to work with, eucalyptus in Argentina, and those grow so fast. Almost there. Oh, that's a unique ring. Look. Huh, super cool. Something happened on that ear. Yeah, I would say it's highly unlikely that that one is a false ring. False rings sometimes look like a little ghosty, so they're not as clear usually, depending on how severe the environmental conditions that cause them. But for many like severe events, there's usually some sort of a record. Either someone knows that there was like a fire or beetle infestation, or yeah, you can detect anything really on, as long as that specific tree was affected. Something that we've learned here in boreal and also other forests is that not every tree will respond to, for example, drought or something. Every tree is unique. Here in boreal soils, there's sometimes pockets of water across the landscape, and they kind of, let's say, protect some trees from severe environment. Almost there. Yep, this. So we have 83. Maybe we are going to get down to 85 potentially. Let's see if we get how many. Alright, so I don't know. My eyes cannot detect the last one. Let me zoom out, see if I can grasp something. No, I cannot. I don't know if that is a full ring or what. I do know that's the pith though. This here for sure is the pith, so I guess we can consider that the first one. Yeah, we will leave it at that. If that tiny thing is the pith, then could potentially claim that the last one goes to here, maybe? Yeah, maybe. Alright, let's save it just in case. Same thing as the other one. Where's the region of interest? Right there. Select them all. Come on. Sometimes my computer gets stuck and it won't select all, so I don't know. And then we're going to do measure. And whoa, what happened? Why are these units so large? Did I forget to 20? That looks like pixels to me. Alright, well, maybe those are pixels. So consequently, maybe I need to set the scale again. set the scale again, tell FIJI that is 150 millimeters. Okay, now we will request to get a measurement again. Measure them all again, please. Yep, that makes a lot more sense. Okay, same thing. Save with the exact same name of the file. Svarberiet perch 07, and we again save the region of interest as the same name. And then done. That's all. That's the entire process. Then we just close everything. Sure, save as overlay. Close everything. I don't need to save this image. And that's all. That's how we end up with one image, one CSV file, and one zip for each image. And we should have those for each and every tree core. With those, eventually we're going to process those data and build graphs like this one. Oops, no. Yep. I here have not corrected for false rings and missing rings and things like that, but it's pretty cool that from the samples we have processed so far, there's already some sort of a trend, and some I guess this is the mean of many trees. Red is pine, blue is spruce, purple is birch, and then the mean of all of them. But of course, something that you cannot see here because I'm not plotting individual trees is their establishment time. Like many were established in the 1900s, many trees were established in the 1940s, and others are more recent. Right. But overall, there is some sort of a trend, really interesting trend. And I normalized these values just because, what is Nala? I normalized these values because the idea was just to show them all on the same graph. Otherwise, big trees will just be way up there, small trees will be way down here, and we will not be able to compare the actual trends. That's what I used to see if I'm missing rings or if there's a false ring, etc. I look at the trends and try to see that they sort of kind of follow a slightly logical sequence. Or here we can tell that all species go up, but sometimes they go down, and sometimes they contradict each other. Like for example here between pine and spruce, they went in opposite directions during drought. And yeah, I need to make sure that's okay.